Ladies and gentlemen, my next project has been baking for a long time, but it's finally ready to be served. Let me show you what we have on the plate with a nice glass of red. For a starter, we have a black charcoal light with a golden grill. Careful, hot, you might burn yourself. Next up, we have a creamy grey base served on a bed of golden shine, perfect for that summer eve. And when finished, you can add some extra energy to the mix. Ain't that hot? For dessert, we serve a transparent orange peel sorbet, cause it's not only the outside that counts. But in all seriousness, let me show you how to make these lights. Here's a quick preview of the render of my SOLUMEN light in Fusion 360. And Fusion 360, you might ask? Yes, I finally bit the bullet and started learning this software instead of 3ds Max, like many of you suggested. In this video I won't go into detail as to how I designed it in the software itself, because I was still learning and I made way too many mistakes along the way, but I will take you through the process of how I got to the end result and then show you how to make it yourself. After a quick inspection from my Meow Spectre, I checked if my prototyping electronics would fit into the base, and that really proved not to be a problem. Oh, and if you want to see how I made the electronics for the project, I already have a video about that on my channel. Now let's continue with the video. To get a real first glance at the light, I added a quick plastic dome from a garden light to see how that might look, and to be honest, I really liked the look of that already. But I wanted more. So I started designing a proper tube that kinda looks like a retro gas burner grill. I printed this on my Ender 3, but that proved to be harder than expected with all these retractions. Although it was quite a nice end result, it blocked way too much light because of the thick plastic, especially when viewed from above. I quickly designed something else to try a different technique. So I tried printing straight onto tracing paper, which turned out to be way worse, and it didn't want to stick properly and it generally looked like crap. So that was not an improvement. I tried printing straight onto tracing paper with a laser printer, which gave it a very cheap look in my opinion. So on to designing again and trying to make the walls thinner so more light can go through. And to my surprise, it didn't make it that much harder to print. And it looked really nice in my opinion, so I'm quickly finishing this off so you can see how that looks if you want to print it on an FDM printer like I did. Here's a quick overview of all the iterations that we had so far, with the last two being this black one and the white one being the end result. But the perfectionist in me wanted more detail, and that's why I bought myself a Halide 1 so I can dip my toes into the new waters of resin printing. I was really amazed about the quality that came off of this machine. After slicing the tubes in Lychee Slicer, as by magic the tubes appeared out of the resin. I quickly made myself a curing station out of a UV LED strip that I had laying around, because before curing the tubes turned out really soft like you see here. So in their curing station they went to toughen up. After 15 minutes of their revitalizing beauty sleep, they were really strong. Then I did some final cleaning up with a precision knife to arrive at a, in my opinion, better than I could have ever dreamt of end result. I mean seriously, it almost looks like it comes from a factory. After that, I started designing some flames and a light bulb that I integrated into the base so you can select between the steady and the flickery flame mode. Then I manually added some supports so that it wouldn't affect the looks of the end result. But this print didn't turn out as I would have liked, so I made a couple of iterations on that and I ended up with this. So I made a final selection and went for a final check with the supervisor. And she hated it. Nah, she loved it. After I made this video and I made some lights myself, I did some final tweaks so it would be easier to print, and this file you'll be able to download. And now on to finishing the base. First up, I started modeling the little hole at the front of the light where the low battery indicator LED will sit behind. I wanted this to be as subtle as possible so that I wouldn't ruin the final look. After finding the perfect fit, I added it to the 3D file, like so. At the top I modeled the holes for the charge indicator lights. I made some brackets that hold the 18650 batteries in place, 2 holders for the capacitors and a hole for the potentiometer. Then I tried fitting the base onto the build plate of the Halide 1. That proved to be not quite as easy as I would have hoped, but I can't really complain because the price of the Halide 1 is so cheap, and in the end I made it work like this. After washing the print, I like to dry them with a hairdryer before curing. Then I removed all the remaining supports, after which I test fitted one of the final bottom plates, which showed me if the design that I made on the computer worked in practice. And look at the snug fit of the glass. After that I added my prototyping electronics and everything seemed to fit great. Ta-da! The next thing I needed to do is design the charging station. Once the basic shape was finished, I started adding a hole for the USB-C connector, then some little brackets to hold the cables in. Then I designed the bottom plate for the charging station with a little reservoir to add some weight by adding cement. Following that, again, I added some manual supports, let the software add some braces for strength, and there we go, printing. And again, I'm very happy with the end result. Look at this. All these files should also be printable on an FDM printer. And now that the prototyping phase is finished, I can show you how to make the real light. Oh, and if you like my project, please don't forget to subscribe and hit the bell so you get notified by my next upload. Now, let's start building this thing. The first thing we need is the top part of the light, so we can start filling it up with the needed components. Next up, we'll add two beefy capacitors, 6800 microfarad each. We'll put them in the slots that I designed for them, and if your printer's dialed in nicely, it should be fitting very snug. Next up, we'll fold the leads together, positive to positive, negative to negative, so we'll put them in parallel, thus giving us a 13,600 mAh capacity, which after testing turned out to be the perfect size to get rid of the flickeriness from the pulse width modulation that's generated by the LED, giving us a nice, warm, realistic flickery flame effect. Next up, I'm grinding away the spot welds. These cells are brand new, however, and test their full capacity. I bought them at a discount, being reclaimed due to spot weld error in the factory. Next thing we need are those two battery holders that are also in the 3D files. I personally printed them on my SLA printer in PATG. Then we cut a bit of nickel strip. The next thing I'm doing, cutting the nickel strip again in half, you won't have to do, because there was a mistake in the 3D file at the time that's long been resolved in the final download. After that, it's time for spot welding. So here I am welding to my stupid compromised little strip, but it does also work. Let's now do the bottom. Somehow I really like the spot weld, it's really relaxing to me, and I really don't mind if I have to do a whole bunch of batteries in a row. Anyway, some solder in the middle of the nickel strips on both sides, after which we'll take some wire, and I bought a whole bunch of these high temperature silicone wires. They're really nice to work with. I would never want to work with anything else anymore. And they come with the added benefit that you can just strip away the insulation with your fingernails. So let's add some solder to that and connect them to the battery with obviously the red to the positive, and in this case I used blue for the negative. And with that done, we can finally put it into the base. Next up, I printed two of these bridges that will hold the batteries secure into the base. These are the type of screws we need, so let's take one of those and screw it into the little bracket. And into the base. There we go, firmly attached. Next up, we need a potentiometer, a B50K, and that one goes into the big hole in the front. We hold it so it doesn't fall out. We add a washer, then a nut, and we tighten with some pliers. Very nice. Then we take the heatsink, and after that we take our LED, which is a... what is it actually? Let's see, I just buy a little bit of stuff on AliExpress. Oh, there it is. It's a 3535 LED. So it needs a special heatsink as well, and solder paste to put it to the heatsink. And at first I was like, is this too complicated for this project? Will people be able to do this? Because they need a heat plate and everything. But then I thought, hey, I don't need a heat plate. Let's just take a pan, something everybody has. And this turned out to be quite a good solution. Poor man's do-it-yourself way, and this is also very satisfying. Look at it flow. It's like baking an egg, but better. Is breakfast ready, honey? Oh yes it is. It might enlighten your taste buds. But jokes aside, let's see if it works with a very low voltage of 2.5 volts. If there's no short, and that seems to be perfect. Next up, let's take a yellow and a purple wire. Remove the casing using the nail stripping technique. Again, we add some solder, as well as to the heatsink itself. For this you need to set your temperature of the iron a little bit higher because the heatsink draws away the heat from the iron and makes it harder to solder to. And that's the light part finished. With that done, let's put it into the base like that and put a little dab of super glue in the middle. Pull it down and hold it. So now we have purple and yellow for the LED and blue and red for the batteries. Let's now add some more colors to the mix. Orange goes to the middle. Oh, and don't add the green wire. That was a mistake on my end. I removed it afterwards, so the left pin doesn't need a wire. Next up, we solder the white wire to the right pin in the back. Next up, we'll take some brown wire that will connect to the two front pins. Those are for the on and off switch. For good measure, I like to add some heat rings. If you print it in PLA, be careful with the heat. And that's when the penny dropped that I didn't need a green wire. Now some gray and black for the capacitors. Gray goes to the positive side and black to the negative. And I don't like these contacts to be exposed like that, so I put some Kapton tape on top of them. And that's the top part of the base ready. Now let's go over to the bottom part. Here we'll add a switch that'll let you decide if you want flickery flame mode or steady light output. As per usual, I added some dabs of super glue, which I spread around with my tweezers. Then added the switch, like so. Next we'll add the charging contacts. We'll take the one with the smallest contact in the middle. 2 more dabs of super glue and add the contact. Next up, we'll take our boost converter and connect it to a power supply, which we'll set to 3 volts, indicating an empty battery. Then we'll turn it down until we reach round about 3.9 volts. This will make sure that we have a stable voltage output and the LED won't dim over time as the battery drains. With a full battery, 4.2 volts, the voltage of the boost converter will also rise a tiny bit, but it's basically insignificant for the light output from the LED. Now let's take our lithium charge / protection board, and the first thing we need to do is remove the LEDs from the board. We're going to move them to the top of the light. You can either do like I do and remove them from the board and try to recover them, but I have to tell you, it is really not as easy as it looks on this video. These LEDs are super tiny, and you really need a steady hand for it. Also, to solder wires back to it, which I'm using some annealed wire here and a bit of tape that I rolled up to try to keep them in place. It's really almost impossible to do without a proper heat gun, a good microscope and a fine tip on your soldering iron. For the people who aren't up for the challenge, I'll link some LEDs with wires attached to them in the description. Now we'll add the boost converter, then the charging board, and last but not least, the heart of the project, aka my self-designed circuit board, of which I'll post a separate video on how to make it, because it's quite technical and it would break the flow of this video. But now let me show you how to connect all the wires. First up, we'll take a blue wire and connect it to the negative of the charging board and to the ground of the magnetic charging plug. Then we'll do the same for the positive sides, but for that we take a piece of red wire. Personally, I like to put a little bit of solder beforehand on all the connections. Next we'll connect the black wire, which is the negative from the capacitor bank. Next up we'll add the grey wire coming from the capacitor bank to the middle of the switch. Then we add the purple wire, which is the negative from the LED, together with the black wire from the capacitor bank. The positive wire from the LED goes together with the grey one. One of the brown wires from the potentiometer to the input of the boost converter, and one to the battery positive of the charge port. The white wire from the potentiometer gets connected next to the purple and black wire. The orange wire coming from the potentiometer goes to the output of the circuit for the flicker or steady setting. The negative of the battery to the negative input of the charge port. Positive lead of the battery to the positive input of the charge controller. Next up we'll add a short blue wire next to the white wire, which will connect to the negative output of the boost converter. Like so. Next up we'll add a green wire on the side of the switch with the flickery flame mode. We'll cut it short, then we'll take a purple wire, which we'll add on the steady mode, and they get connected to their respective circuitry. By the way, you can use thinner wires for this project with a minimum of 28 gauge. Next up we'll add the short blue wire from the negative input of the boost converter to the negative output of the charge controller. Next up we'll add 2 thinner wires to the battery indicator circuit. And we'll connect the positive to the positive input of the boost converter and the negative wire together with the negative lead of the battery. We're almost finished with the circuitry. Now a little short red wire from the output positive of the boost converter to the middle pin of the switch. But as you can see, they didn't like to stay together on this one pin anymore, so I'm first soldering the 3 wires coming to the middle switch together, after which I soldered them as one bunch together to the middle pin. That's better. Here we are. Let's turn it on. There's a little delay, that's the capacitor charging up, and then we have a nice and steady flame. Look at this, and we can completely decide how much brightness we'd like. So if we switch it from flame to steady, you can see that it is completely fixed, and the steady mode is also dimmable. Next up, we'll take the charge indicator LEDs and put them through the designed holes for them. Then we take a little dab of super glue, put it underneath the LEDs and push them down. And if all went well, they shouldn't be sticking out and the glass should be sitting nice and flush with the surface. Now set your power supply to 2.8 volts and connect the wires until you figure out which is positive for blue and which is positive for red. Then we'll add the negative for red, the positive for red. That seems to work. Then the positive for blue and the negative for blue. Alright! Put some shrink tube on the low battery indicator LED. Then we put it in the designed holder. For me it really sat nice and stuck in there. Next up we need these type of screws. And we're finally ready to put all the wires together into the base and start closing it up. And that's done. I am really loving how this is turning out so far. Also, I'm still stunned by how clean it all looks and how sharp it is with this resin printer. It's a big mess to print it, but oh, the results are nice. The little lens that sits on top of the LED is made out of a type of gel. I removed it because without it, strangely enough, the color temperature is warmer. Now let's start focusing on the charging base. First I need cement, which is rapid cement, because who likes waiting? I just randomly added cement and a bit of water and started mixing until the measurements seemed right. Then I added the thick sludge to the charging base, which makes it feel more hefty and makes sure that when you lift the light, not the whole contraption comes off the floor. Then I used a massage gun to get the bubbles out. It's not necessary obviously, but I had it laying around. And then make sure it is flat so it doesn't stick out. I tried printing the base in all types of materials, so you can see that you don't need an SLA printer with resin per se. This is wood PLA, this is some normal prototyping gray PLA, and this is the one with the resin printer, which I will use for the demonstration here. Next up we'll need the charge connector with the thicker pin in the middle, and it will go there, but in this design I still made it a bit too thick. I changed that around in the new design that you will be able to download, so you won't have to do any grinding. And like that we glue it to the base. Now we need the USB-C connector, which comes with a little rubber ring around it, so it will also sit quite nice in there. As you can see, you have to like wiggle it in and then put 2 screws in to fix it to the charging base. Then we'll add some solder to both of the contacts and we'll add some wires to connect it. This is really basic, obviously, definitely compared to the other electronics we did before. Just put it through all the holders and connect it together. Done. Now let's see if the two halves make proper contact with the magnets. So we'll turn it around, put the USB-C in, and there we go, we have the charging light. So that is a go. Now whenever the cement base is dried, we can also add it. As you can see, there's a little indentation which need to line up. Then we'll add screws and voila! And as you can see, the base has 2 different colors now, which bothered me personally, so I took a spray can of a bit darker gray and made sure they matched up. Then onto the glass dome. I tried cleaning it with some screen cleaner, but look at that. Terrible effect. So I went to the kitchen, used some proper dish soap and warm water and really cleaned them good until they were shiny. So as you can see, that works very well. All there's left to do now is finishing the light tube. For that we'll need some tracing paper, which we'll cut in an 8 by 10 centimeter piece. At first the piece will probably be a little bit too big still, but it's better too big than too small because this way we can still cut pieces away. As you can see, there's still a little bit extra, which I did slice by slice until it fitted perfectly together. After that, I used my knife to put little dabs of super glue underneath the paper bit by bit to stick it to the edge of the tube. After it was in the correct spot, I used some extra glue on top of the paper to really fuse the 2 halves together all around in the inside of the tube. I did this at the top and the bottom and also along the seam, because with the heat from the LED it tends to curl inward, so it's very important that the 2 sides are really sticking together. After that, put the tube on another piece of tracing paper and trace around the edges. Then cut it away with some scissors. Next up, put one of the plastic rings also provided in the description onto the tracing paper and make sure that it's really nicely cut around it. Next up, we put some super glue on the top part of the light and we put the thing we just made from the bottom end into the tube and we push it onto the glue part. So we end up with something like this. Then I cleaned up the base with a pencil eraser and removed all the last little bits of dust with a brush. After which I used a generous amount of super glue on the inside of the tube and put it onto the base with a bit of weight on it until dry. When the glue is all hardened, we can move on to do the same with the glass dome. Ta-da! There we go. Wow, I'm so happy with this. And the charging base also works perfectly. Now let's start a timer to do a battery test. And I'm very happy to report that 18 hours and 20 minutes in, it was still going strong on max brightness. In the end, I measured 25 hours, and if you get higher capacity batteries, you can probably boost that number even more. And when there's about 10% battery left, the little red LED at the front will turn on. And when you put it on the charging base, like shown in the intro, the nice red LED underneath the glass will illuminate the edge. And when charged, it will turn into a blue light. Now I'll show you some extra footage of me making the other lights. And that is the project finally finished. Wow, it took me a long time to finalize this one. I really underestimated it by a long shot. In the end, I had around 800 gigabytes of footage coming from 4 cameras, plus screen recordings, 3D animations, and all of this I had to synchronize into a multi-camera timeline. Needless to say, Premiere didn't like me for that. Every cut I made, I had to wait about over a second for it to respond if it didn't crash altogether. I should really try learning DaVinci Resolve because Premiere just gets buggier by the minute. But on the other hand, learning new software also slows down my workflow again, so I'm a bit undecisive. On top of that, I'm currently working 2 jobs in combination with this channel, which is one heck of a busy schedule, but my dream is to build SOLUMEN Film to the point where I can leave one of those other jobs to focus more on what I really love doing, which is what I'm doing here. And now, thanks to all of your positive feedback and interactions, I can really see this dream becoming a reality. Please keep the feedback and project suggestions coming. I'm really reading everything. And here is where I'll leave it for now. Please don't forget to subscribe and hit the bell so you get notified whenever I have something new to show for, and help me get closer to my dream. I also made an Instagram and a Twitter page where I'll share more frequent updates about the progress of my projects, so feel free to join me over there. Thanks for watching, and I see you in the next one. Bye!